In today's session, we are going to learn how to integrate HashiCorp Vault with Terraform. We will cover everything from setting up Vault on an EC2 instance to using Vault's AppRole for authentication with Terraform. Let's dive in. First, let's open the AWS console and navigate to the EC2 service. Now, we are going to launch a new EC2 instance. Then select Ubuntu for this demonstration and scroll down and select the key pair. Then download the key pair into your system. This key pair will be used for connecting to the instance. Once the key is downloaded, hit launch instance. And as you can see, our instance is created. Once the instance is running, we will SSH into it using our key. Now let's move to our GitHub repository, where we have our necessary commands for the setup documented in a markdown file. After reviewing the steps, open your PowerShell or terminal. So I will open PowerShell and connect to the EC2 instance using SSH. So let's move to our download directory. I will type cd Now I will run ssh-i and our key pair value file name, which is east2.pem. Then type ubuntu @ and your instance IP address. So let's move to the Amazon console and copy the IPv4 address and paste over here. For the explanation of the command, we use the SSH command to connect to our EC2 instance using the private key we downloaded. The I flag specifies the identity file, which is a key, and the Ubuntu @ your instance IP is our login credential and instance IP to connecting our EC2 instance. So I will hit enter and I will type for confirmation yes. As you can see, we can successfully connect it to our Ubuntu machine. Once inside the EC2 instance, let's begin by updating our system and installing GPG, which will help in verifying HashiCorp's package signatures. So let's move to our GitHub repository and scroll down and copy the command and paste over here. The apt update refreshes our system package index, and apt install GPG installs the GNU privacy guard to handle key verification, ensuring that downloaded packages are authentic. So I will hit enter and it will start updating our packages. Now it is successfully completed. Next, download the HashiCorp signing key and install it into a new key ring. So copy the command and paste over here and hit enter. This command downloads the HashiCorp GPG key and saves it into a system-wide key ring. This key allows us to verify that any packages downloaded from HashiCorp repository are legitimate and have not been tampered with. Now let's verify the key's fingerprint. So copy the command and paste here. This command verifying the fingerprint ensures that the downloaded GPG key matches HashiCorp's official key. It's an important security step to prevent malicious packages from being installed. Now, add the HashiCorp repository to your system. So, copy the command and paste here. Here, we add the official HashiCorp repository to our source list so that our system knows where to download HashiCorp Vault and its dependency. Now, our next command is sudo apt update. We update our package list again to include the new HashiCorp repository and then install Vault. So I will type sudo apt install Vault and hit enter. And it will start installing a Vault into our system. Now as you can see, the Vault is successfully installed into our system. Now let's start Vault in a development mode. So the copy command and paste here. This command starts Vault in a development mode, making it accessible on all interfaces using port 8200. This is useful for local testing and demos. Now, let's copy the export command and open a new PowerShell. Then move to our key pair directory. So cd t and cd downloads. Then type sh-i east Ubuntu @IP address and hit enter. This command will use for connecting our Ubuntu machine into our PowerShell or terminal. So let's move to the another terminal and copy the export command and paste over here. Now let's open your browser and navigate to the IPv4 address of your EC2 instance. So I'll copy that and paste over here, then type :8200 and hit enter. It will take us some time. It will give me the error because we don't allow inbound traffic. So let's configure inbound traffic. Let's move to the AWS console, then go to the security, open the security groups, then edit inbound rules. So let's add the rule. I will enter 8200, then select 0.0.0 and save the rule. Now as you can see, our security groups can be updated. So let's move to the another tab and refresh this. Now as you can see here, the Vault page is open. Now it will ask for token. In the terminal where Vault is running, you will see a root token. So let's move to the terminal and copy the root token and paste into the Vault login page and then click signing. As you can see, our signing is successful. Once login, let's explore Vault secret engine. So navigate to the secret engine tab and click on the enable the new engine. Select the KV secret engine and leave the name as KV. The KV engine stores arbitrary secrets in a simple key value format. We will use this to store sensitive data that Terraform can later access. So click the enable engine. Now create a new secret. So I will enter path to test secret, and under this path we will store a key value pair. So I will type key username and value *cloud. We are storing some credentials username as the key and the *cloud as the value that Terraform will later access to Vault. So save it. Now let's configure Vault to use the AppRole authentication method. Go to the Access tab and enable new method. Then select AppRole and enable it. AppRole is a machine-centric authentication method that allows us to generate role IDs and secret IDs, which can be used for automated access, such as from Terraform. Now let's move to our GitHub repository and scroll down. Now I have already written a policy in our GitHub repo. So let's copy and paste the policy into the terminal to assign it to our AppRole. So let's copy and paste the policy into the terminal to assign it to our AppRole and hit enter. As you can see, the policy is successfully uploaded. Now let's run the command for creating the AppRole. So I will copy from here and paste over here and hit enter. As you can see here, the data returned successfully into our auth AppRole role into Terraform. Now let's generate the role ID and secret ID needed for authentication. To generate role ID, copy the command and paste over here and change the my role into Terraform, because we use here Terraform. So replace the my role into Terraform, then hit enter. As you can see here, our role ID is displayed. Now let's generate our secret ID. So copy the command and paste into terminal and replace my role to Terraform. Then hit enter. As you can see here, our secret ID will be generated. Now for explanation, role ID is static and used to identify the role, while secret ID is dynamic and change over time, making it more secure for authentication. Next, copy the role ID and secret ID and paste them into the main.tf file of our Terraform configuration. Now let's open our GitHub code space. And I have already opened and configured it. So navigate to the Day-7 folder. I type cd Day-7 and I will change the role ID. Copy the role ID and paste here. Then copy the secret ID and paste over here. Now let's copy our vault's URL. So copy this and paste into our main.tf file. And in the main.tf file, as you can see, the provider is AWS and region is US East 1, which is default. Then the provider is Vault, and here is the address of our Vault's URL. Then we can assign our authentication login, and here we can assign role ID and secret ID. Then we will assign our data, Vault Kiwi. In my case, the mount is Kiwi and the name is test secret. Now run the following commands to initialize and apply the configuration. So I will type terraform init to initialize our terraform. Terraform init initialize the working directory, and it will start initializing. Then type terraform plan. Terraform plan shows what changes will be made. As you can see here, our terraform plan is successfully run, and as you can see, what changes can be done during our infrastructure creation. So I will type terraform apply. The terraform apply commands applies those changes, and it will ask for confirmation, so I will type yes. And finally, let's go back to AWS, open the instance and check the tag section. You will see the value from Vault has been successfully applied as a tag to instance. This demonstrates how Vault can be used to secure inject sensitive data into Terraform configuration. So that's it for today. We will successfully integrate Terraform with Vault and use Vault's AppRole for authentication. So thank you for watching, and I will see you in the next video.